Am I audible?
Yes, sir, you're audible. And we are talking about operating system.
We are talking about the basic concepts of operating system.
And now, today you told that you start Linux.
So, before I go into the concept of Linux and all, let us discuss about SDLC. What is this SDLC? So, we need to discuss about the SDLC, Software Development Life Cycle. Okay. So, this we need to understand. Software Development Life Cycle. So how the software development will be happen. So yesterday also we discussed about the same. Just giving a small recap of that. So first of all, whenever we want to create a software, the developers will do the requirement analysis, and then they will go for the design, implementation, testing. Finally, it will be coming in the market, and then monitoring and management will happen. So these are the things that will happen in the software development lifecycle. So in the software development lifecycle, we are having agile model, waterfall model. These are the two types of. Now, what is this agile and what is this waterfall model? Okay. So what is meant by agile model and what is meant by a waterfall model? Agile, previously we used to have waterfall model. We used to have the waterfall model, and now we are going with the agile model. What is the main difference between waterfall and agile? So let us understand. So have you ever gone to any waterfalls, near to any waterfalls? Whatever the water that is coming from the top to bottom, we cannot reprocess that. Again, I cannot shift that to the top. Okay, so in the same manner, uh, if you see, whenever a software is developed, so that software, whatever the software that got developed, so that will be from the stages wise. If there is a problem with a single stage in the waterfall model, we need to reconstruct everything. Okay. So here you can see what is SDLC waterfall model. Okay. So if you see here, a waterfall model in software development model, use it in the context of large complex projects, typically in the field of information technology. It is characterized by structuring and sequential approach by project management and software development. Waterfall model is useful in situation where project requirements are well defined. So you need to get the complete project requirements. If your project requirements are very clear, okay, your project requirements are very clear. Okay, then we can go with the waterfall model. And the next one is here you can see are well defined and project goals are clear. It is often used for the large scale projects with long timelines where there is a little room for error, and the project stakeholders need to have high level of confidence in the outcome. So this is about the waterfall model. Whatever that is happening, whenever you want to develop a software, the software will be developed with a clear cut understanding. What are the requirements? What is the software that we want to develop? What is the application that we want to develop? What is the software or else runtime that should be running that should be there? Either we need to have Java or else we need to have Python. So which type of application that we need to create? You need to have that in a fully concentrated way. And then you need to understand each and every module, what should be there inside that application. So which kind of module should be there in the application. Everything you need to have a clear picture. If you are having any confusion, then waterfall model is not very helpful. Why? Because if you see here, phases of waterfall model. Classic waterfall model divides the life cycle into set of phases. The development process can be considered as a sequential flow in the waterfall. So the different sequential flow waterfall models as like this. So you will be collecting the requirements from requirement to design. So you are going to design and then development, testing, deployment, and maintenance. So this is the sequential step-by-step process which we are going to take, which will be taking place in the application development. So first you will gather the requirements from the client, and then you will understand, you will create a blueprint of that application. Later you will develop the application. Once the application is developed, then it will be tested. And if the application is bug-free, everything is clean and clear, then it will go into the deployment. And once it goes into the deployment means it will be running in the production level. It will be running in the servers, installing. Simply, if I have to say, the application will be installed on the production servers and that will be running fine. Okay. And after installing the application, we need to do the maintenance. Maintenance in the sense, what we have to do, we need to monitor the application. We need to check whether the application is running fine or not. Is there are any CPU hikes, RAM hikes? If the application is consuming more amount of CPU, more amount of RAM, all these things we need to understand. So this will comes under the maintenance. So now what is the difference here? So this is what they are saying: requirement analysis and specification. Requirement analysis and specification aims to understand the exact requirement of the customer and document them properly. So documentation, documenting the system, customer requirements is very important. So now we used to do that. So in my previous company, not only in previous company, but as a manager position in the previous company, I used to do that. So what I used to do here is, first of all, I will try to understand the requirement. So we will take a call with the customer. Okay, whoever is the customer, customer in the sense, not we, normal clients, the banking clients, whoever are the bank managers, they are the customers. E-commerce website, so whoever that e-commerce website belongs to, those are the customers to the IT company. We will talk to the customers. So what we are going to talk, what are your requirements? So how you want to develop the application? What is the expectation towards that application? So everything. So whatever we are going to create, we are going to write it in a document format. So what are the things that our company will do? So we are going to create that in a clear-cut document. So we want to create. So as per the agreement between the client and the company. So the client means the customer and the company, IT company. The IT company has to develop these applications. So these are the modules that should be developed by the client company, and then these are the things that should be done by the client company, by the company. So we will write it in a documented format, and those documents will be given to one document will be given to the customer, and the other document will be kept with us. So that will be like a mutual understanding between the company, IT company, and between the customer. So this is what requirement gathering is all about. So once you have to correct the requirement from the customer, and then you have to document the documentation. In IT industry, documentation is very important. Your manager will say that your manager will drop a mail to you, so that he will say that you have to do something. So whenever you are doing, you will face a lot of problems. So if you document that particular problem, that will be helpful for you whenever you are doing whenever you are recreating the same thing in the next session. I mean, if you are creating a next application, if the same process is there, then you can see if there is an error like this, then what is the solution for this. If you document that, that will be very helpful. So between the client and the company, documents are very important. And whenever you are doing any work, whenever you are doing a troubleshooting, whenever you are doing a error, or also you are trying to remove the errors, you are doing the troubleshooting, you are finding the warnings, everything you have to put in a document. If you have that document in your hand, that will be very helpful for you. I know one of my colleague who will do this document. So there are large number of people across the we used to give the applications to the African banks. So these African candidates, whoever are the banking candidates are there, they are very interested to take that documentation. Why? Because they don't know what are the errors that they are going to face. So that's why documentation plays a very key role in the IT industry. So whenever you are working with the IT industry, it is more important that you need to maintain the documentation. So this is the first thing. And the next one is requirement gathering. Firstly, all the requirements regarding the softwares are gathered from the customer, and the gathered requirements are analyzed. So the goal of the analysis part is to remove the incompleteness, okay, and inconsistency. Incomplete requirement is one which some parts of actual requirements have been omitted, and inconsistency. An inconsistent requirement is one which some part of the requirement contract detects some another part. So here, what is going to happen? For example, contradicts. Okay. So for example, what is going to happen whenever, if I ask you, okay, if I ask you, for example, I ask Abhishek, why you want to learn DevOps with AWS? So if he gives me the clear-cut analysis, so this is the reason why I want to, this is my requirement, why I want to learn DevOps and AWS. So I will have a clear picture of that. For example, Abhishek is my customer. So he came to me and he asked me that I want to have an application. So when I ask the which type of application you want, what is the color grading, what is the icon, how you want the application. So I have my requirements to develop that application. So if he says that do whatever you want, do whatever you are interested, you are not, I'm not going to ask you anything. So if he says that, then there will be a very big problem. Why? Because I will create my own application, I will submit it to him. The requirements are not clean. So then what he is going to do, he will say that this is not what I required. Then you have to give me the clear cut requirements. You did not give me the clear cut requirements. So how I can develop an application? So this communication will happen between the customer and the client. So the application will be delayed. At a particular point of time, the application may be given to another IT company also. So requirements should be very, very important. So you need to understand what is the customer requirement, and customer has to give a clear cut requirement to the IT company. It's your responsibility to ask. Whatever the minor doubt is also there, you have to ask it. And then designing. So the goal of software designing phase is to convert the requirements acquired to SRS acquired in the SRS into the format that can be coded in the programming language. It includes high level and detailed designing as well as overall software architecture. Software design document is used to document all of the efforts. So high level design and low level design will be there. Okay, this focus on the outlining the board structure of the system. It's highlighting the key components and how they are interacting with each other, giving a clear overview of the system's architecture. Once the high-level designing is in the place, this phase zooms into the detailings. It breaks down each component into smaller parts and provides a specific how each part will function, guiding the actual coding process. So we did not understand this. So it's very simple. For example, uh, for example, let me go with an e-commerce website. There is an e-commerce website is there. So in e-commerce website, there will be user management and there will be order management and there will be inventory management and there will be what I can say, there will be another kind of thing that is notification or else payment management or else payment service is there. And later we will be having one more service that is notification service. So for example, if a user is there, so user logged into his e-commerce website. Now what this user has to do, user has to put an order. He wants to keep an order in Flipkart or Amazon. So then he will trigger an order service. So now when he goes to the, so he needs to, this user service has to communicate with the order service. Once you update the cart, so you select a mobile. So when you select the mobile, you want to purchase the mobile. Then in the subcategory, in order subcategory, you will have a cart. Cart service will be there. So this is what they are saying. There will be cart service. What this cart service is going to do, here you can see. This is what. So once the high level designing is done, high level designing in the sense how the components are communicating. One component is communicating with another component, how it is communicating. One service is communicating, should communicate with another service, how this is communicating. And later inside that service, we will be having some sub-services. That is what. So the phase zooms into the details. It breaks down each component into the smaller parts. Each component in the sense, each service. For example, user service is there. User service will have user login service and user sign up service. And then he can log in with the Google or else Facebook, okay, any social media like that also we can manage that. So user is having two types of services. One is login service, sign up service or registration service. Once it is done, once he logged into the system or else logged into the application, then he will be having the orders service. In order service, again, there will be a subcategory. Either he can go for the cart. So cart service will be there. From the cart, what should be happened? Once he has added the item into the cart, then this service should notify then this service should be notifying the inventory service. Inventory service will be there. What order service will notify to the inventory service, saying that, for example, a mobile is there, iPhone is there. So user want this iPhone, he has added into his cart. So now the inventory service will understand, okay, an iPhone is added into the user's cart. Then what is going to happen? Then immediately the inventory service is not going to be updated. So now what is happening here? Then the order service will take you to the payment service. So the payment should be, I mean, the whatever the phone that you are purchasing, the payment should be done. So this payment service will be there. So order service should communicate with the payment service. And once the payment is done, then a notification, payment service will trigger the notification service. This is your notification service. Notification. Then this notification service will send an email, or else it can send the messages, SMS to the end customers. So this is what going to happen. Now, once the purchasing is done, then what order service is going to do? Order service will tell to the inventory service saying that, or else the payment service that will confirm to the order service that the whatever the mobile phone that the user want to purchase, that is completed. So now what order service is going to do? It will go to the inventory service and say that reduce one of the mobile from your database. So for example, for the sale, whatever the big billion day sale that is coming, from the big billion day sale, if you are having some 10,000 iPhones are there, from the 10,000 iPhones, you have to remove one of the iPhone from your inventory. Why? Because already it is purchased by a user. So now inventory service will update it to 99,999. 9,999 mobiles are available in my inventory. So this is how the order service, the entire e-commerce website will be functioning. So now if you see here you are having multiple services which are communicating with each other, and as well as there are some sub services which are working with those services. So this is what they are saying, high level design and low level design. Now, do you understand what is the designing part here? Any questions? Now, do you understand what is this designing part? Any questions? Any questions, guys? Any questions?
No, Chaitanya.
Okay. So it's very clear, right? Do you understand or not? So is my flow is very fast or what? You can give me the feedback so that I can make it very comfortable for you. Otherwise, you don't need to struggle a lot, okay, for understanding.
Yeah, no problem. I think fine.
Your voice is very low, Hemraj. That's okay. Thank you. Now let's get back to the next concept. So this is about the designing part. So I can tell you without seeing these concepts also, but if you see, you will get a documented format. Okay, this is there. So in development phase, software designing is translated into source code using a suitable programming language. Thus, each design module is coded. The unit testing phase aims to check whether each module is working properly or not. For example, here we have created a user module. So there is a user module. This user service will be written in Java. So they are going to write that. So this is what going to happen in the development process. So we understand that. First of all, we will design it. So there will be multiple modules which should be communicating with each other. Among those, what is going to happen? The user module should communicate with the orders module. So that we will design it and then we will develop this module. So with the help of Java, or else we can use with Python, or else we can go with the .NET, any kind of software programming language, we are going to work it out. And then this module will be done. Later orders module will come. So we are going to write that in the same Java format. And then so like that, what we are going to do, each and every module will be developed. So that is what they are saying here. In development phase, software design is translated into source code using any suitable programming language. Thus, each design module is coded. The unit testing phase aims to check whether each module is working properly or not. Have you ever heard this word called as unit testing? Any developers? What is meant by unit testing?
It's functionality testing. Means whatever the developer is developer functionality. So you have to write a unit case and test that functionality is working on.
Very good. Are you a developer?
Yeah, yes.
Will you do the unit testing?
Yes.
Sometimes what happens, no, developers will give the unit test cases, unit testing to the testing people only. So that is what going to happen in some companies. I'm not talking about every company. Why? Because I faced it. So that's why I'm saying. So developers will not do the unit test cases, will not provide the unit test cases. They will directly give the application to the testing people. They have to do the testing on that. So it will be very critical. And you know about the developers. I'm not blaming everyone. So I'm not into the testing anyways. So the developers will submit the application by the end of Thursday. Thursday evening, they will submit it. From Monday to Thursday, they will do the development. On Thursday evening, they will give it to the testing people. This is what happens in one of my company. So the testers who are there, these testers are going to claim that within one day, we need to check each and every functionality, each and every bug. And the manager will say that by Monday morning, we need to deploy that application. Okay, so this funny conversations will be used to happen in my company. Okay, anyways, the point is unit test cases should be run. So whatever the functionality, whatever the application that you have created, whether the application is running fine or not, is the functionality is working or not. So these are the things that you need to check. Okay. And later, in this phase, developers begin write the actual source code on the designs created earlier. The goal is to transfer the design into working code using most suitable programming languages. Unit tests are often performed during this phase to make sure that each component functionality functions correctly on its own. Okay, so that is the main work of a developer. Developer has to create the code and he has to do the unit testing. If you don't do the unit testing and give it to the testing people will also do certain testing and they will submit it to the deployment. When we deploy the code, we will be facing the issues. So anyways, so from the top to bottom, developers need to create the application and as well as they have to do the unit testing and then they will give it to the testing people. When this application is given to the testing people, they will do the testing of each and every module. So integrating to the different modules and is undertaken soon after they have been coded and unit tested. The integration of various modules is carried out incrementally over several steps. So sometimes with the help of Selenium, manual testing will be done. Sometimes if you are very familiar with the automation testing, you can do the automation testing. Any which ways, the testing will be happen for that application. Once the testing is done, then you can go for the deployment. So deployment means installing on a server. Once software has been thoroughly tested, it's time to deploy it onto to the customers or end users. This means making the software ready and available for use, often by moving it to live or staging environment. So there will be two environments. After development environment, you will be having staging, or else I will call it as UAT, and there will be live. Live means production. Once development is done, then you will move the application into the staging environment, staging or UAT environment. Again, you will recheck that application, whether the application modules are everything is fine. Whatever the customer requirements are there, did we provide all the requirements to the customer or not? So these are the things that we are going to recheck that, cross-check that. So once it is done, then we will make it available for the end customers. We will make it into the live environment. During this phase, we also focus on helping users get comfortable with the software by providing training and setting up necessary environments and ensuring everything is running smoothly. So this is what deployment is. And the next one is maintenance. So these 5 levels are one way. Those are all one, I can call it as one block. This one thing is a separate block. Maintenance. Maintenance is very, very, very important. You create the application, but you need to maintain it. You purchase a car. Purchasing of car is very easy. If you are having some 3 to 4 lakhs also, you will get a car. But maintaining that car is very important. So in the same manner, creating the application is okay. It is some tough, difficult task, but any which ways, it will be completed by 6 months or 1 year. But later, how we are maintaining that application, how many errors that the customers are facing, how many bugs the customers are facing, how we are going to resolve it, what is the application status, is the application is consuming lots of resources, what is happening with that, everything we have to do. We have to check the monitoring, we have to do the management. So that will comes under the maintenance phase. In maintenance phase is most important phase of software lifecycle. The effort spent on maintenance is 60% of the total effort spent to the development. So that is what I said. So whatever the effort that you put among those to develop an application, 60% of the effort you have to put on the maintenance. Okay. So this is what happens with the software development lifecycle. This is called a software development lifecycle. Forget about waterfall model software engineering, but this is what requirement gathering, designing, development, testing, deployment, and maintenance. These are all comes into the software development lifecycle. Once it is done, then let us understand what is a waterfall model. Waterfall model is waterfall and agile model. 2 types of models will be there. One is the waterfall model and the other one is the agile model. If I have to tell you in a simple manner, okay. So what happens here means in the waterfall model, see there, whatever the design that we have made, that will have a sequential approach. So the waterfall model involves in a sequential approach to software development, where each phase of project is completed before moving into next one. So which means that first of all, you need to get the requirements, step-by-step process. You need to get the requirements and then you have to do the designing, and later you have to go for the software development, and then you have to go for the testing, and then you have to go for the live or staging, and then finally you have to do the maintenance. This is the step-by-step process. Sequentially, you have to do that. For example, you need to create the complete application. Okay, you need to you need to do the complete implementation of the application. Then only it will go for the testing phase. So here we have to rethink about that. So if this application has to go for the testing phase, do I need to create the complete application? So some people will be in a very hurry. So we don't want this notification or inventory service to be updated. Presently, give me the e-commerce website which want only user login, orders, and payment services. That's more than enough. Slowly, we will check out the notification services. If they say like that also, if 1 or 2 services are not mandatory, we have these services are mandatory. So in waterfall model, that cannot be done. You have to give the complete application. So that is one of the drawback. Anyways, they are saying like it as a feature. The waterfall model involves a sequential approach to software development, where each phase of the project is completed before moving on to the next one. Document driven. The waterfall model dependent on documentation to ensure that the project is well defined and the project team is working towards a clear set of goals. So you need to provide a document. So the managers and everyone should be working on the documentation. You have to provide the documents. You need to get the documents. Everything should be clean and clear. So this is one of the main feature. And the next one is quality control. Waterfall model places high emphasis on quality control, testing, and each phase of the project to ensure that the final products meets the requirement and the expectation of the stakeholders. So you understand about this. I don't need to say about this. The quality should be very good. Why? Because it cannot break in the middle. Again, you have to start from the beginning, from the requirement analysis, and then you have to go with the design, implementation, testing. Again, this process will be repeated. If there is any problem in any one of the service, again, you have to start from the beginning itself. So this is about waterfall model. Let us see what are the disadvantages, advantages, and why we don't want the waterfall model right now. Everyone are using the agile model rather than the waterfall model. Everyone are using the agile model. Why? No feedback path. In the classic waterfall model, evaluation of software from one phase to the another phase is like waterfall. It assumes that no error is ever committed by the developer during any phase. Therefore, it does not incorporate any mechanism of error correction. So this is the main important. So what in waterfall model, everyone will think that whatever the software that they have developed, it is correct. So they will go through, even though there are having the bugs and there are some certain problems, still they will go with the phase by phase, and they will say that, see here, it assumes that no error is ever committed by the developer during the phase. Difficulty to accommodate the change request. This model assumes all the customer requirements can be completed completely and correctly defined at the beginning of the project. So this is what I said you in the starting. Requirement analysis. The customer in the waterfall model, what is the major problem here is the customer has to define the what is his or the company requirement is. What is the company requirement? How the application should be there? What are the modules that should be there inside the application? Everything should be clearly declared. If there is any problem after completing the application, once it is driven to the customer, then it is a little bit difficult for the change request. I don't want this module. I want in this fashion. I don't like this feature. For example, you have given the biometric feature, or else you have given the iris feature in the application. You know about the iris. What is meant by iris? Did anybody know about iris? Iris feature. Okay. In application, you will find out this iris feature. Normal applications. What was that? Simple, your eye scanning. Okay. So when you put your mobile in front of your face, it will scan your eyes and then it will unlock. Like that, there will be iris feature. Some applications are coming with the iris feature also. So what you have done, so the the client has requested, I want the high security for my application. You put the iris feature. When it moved into the production, then customers are facing a lot of difficulties with this iris feature. Then the client will say that I don't want this iris feature. You have to remove it. So that is what they are saying here. This model assumes that all the customer requirements can be completely and correctly defined at the beginning of the project, but the customer requirements keep on changing with the time. It is difficult to accommodate any change request after the requirement specification phase is completed. Once this phase is completed, once the requirement phase is completed, so my customer has asked me, I want to have a high security feature for my application. So you gave the biometric, you gave the voice or also speech to text feature. You gave the iris feature also. These many features that you have provided. But still, he may ask you some another feature that is called as change request. So there are two types of requests. New request and change request will be there in the software. Whenever you are developing an application, new request will be there, change request will be there. What is meant by change request? These are also called as CRs. Okay, in IT terminology, they are called as CRs. What is meant by change request? You created an application, and in that application, one feature is not as per the mark, or else the customer is requesting you to change that application, or else change that feature into some another way. So that is called as change request. Now, what is meant by new request or new feature request? So once the application is created, then the customer may ask you for a new feature. So companies will not charge for the change request mostly, but they will charge for the new features. Okay. So this is what happens with a waterfall model. Change request cannot be done. It is difficult to do the change request. Okay, so like that you can go through this. So right now no company is following the waterfall model. Majority number of the companies are following this. Not majority number of companies, all the companies are following the agile model. It will be looking as it is like a waterfall model also, but the main difference between waterfall and agile model is that, look at that. Agile model is primarily designed to help the project adapt quickly to change requests. So the main aim of the agile model is to facilitate the quick project completion to accomplish its task. It's more important that agility is required. Agility is achieved by fitting the process to the project and removing the activities that may not be essential for the specific project. That is what I said, So whenever the same process will be there, requirement gathering, designing, construction, or else implementation, testing, deployment, and gathering the feedback, and again going for the requirements. Feedback in the sense, here you will not have the feedback, here you will be having the maintenance only. But any which ways, the same steps will be repeated again and again. But in agile model, if you are having any problem with a particular feature, you can simply resolve it. You can simply accept that and you can make the changes in that particular service. So that's why major number of companies are going for the agile model. So these are the two types of models that we are having in the SDLC. There are so many things that we have to discuss, but right now this is not the situation. But anyways, when we are going into the DevOps, again, we will discuss about the models. What is waterfall model and what is agile model. But these are the two types of models that are given for your software development lifecycle. Now, what we are going to do here, after, I hope you understand about the software development. So what happens in the software development? Can anybody tell me about this? What did you understand from this entire session? We are talking from last 45 minutes. We are not. I am talking from last 45 minutes. What did you understand?
So different phases: planning, requirement, then planning, then implementation, then testing, then come to again maintenance. So all life cycle for the software.
How softwares will be built. That is what we discussed.
Correct.
Anyone, can you please tell me what is your understanding? Or do I need to call with a name?
Yeah, actually, we simply discuss the software development lifecycle where we follow some approaches like waterfall and agile. And waterfall is a sequential approach, and agile is a iterative approach, right? Where we follow some set of steps. Yes.
Good. Any one person? Anyways, we are going into the next concept. Both we go into the concept. Any one person, can you please tell me what you understand from this entire concept?
I understood that how an application goes from the planning or from gathering requirements to different stages and finally to the customers. How we can take through this methods. That's what I understood, sir.
Okay, thank you. Okay, guys. So let us discuss about the next topic. Just give me a minute. Okay, so this is about the software development. Now, as we are very clear about application will be developed and they will be tested. So now we will be diving into the operating system. So this is not, see, we understand about the application, where these applications will be installed. Applications are running or else installed and running on a server. Inside the server, what you will have an operating system. What is meant by an operating system? Operating system is an interface between user and the computer hardware. So from the childhood onwards, you may know about this operating systems, Linux operating system, Windows operating system, like that. So what is an OS? OS or operating system. Operating system is a interface between the user and the hardware. So if the user want to do a work with the hardware, then definitely operating system will be included into that. Okay. Now, how this operating systems are came into the picture from starting, which from like I might be, I might be sounding something different for you. You have seen only maximum 3 operating systems, if I am not wrong. One is Linux, Windows, and Mac. Yes or no?
Yes, yes.
Okay, very good. So when was this Unix operating system was introduced? Did anybody know about this? Linux
19, I think, forget the name, year 76, I think 70. Okay.
1970.
Yeah.
From 1970, Unix operating system came into the picture. But computer is before 1970 also we have the computer, right? Charles Babbage has invented that, and before that also we used to have the computer. At that
Yes.
time, what we used to have to interact with the computer, how we are able to interact with the computer. At that time, we used to have the low-level languages. Have you ever heard about these languages?
Yes. 8086.
Pascal, COBOL,
Oh,
those are the processors.
oh, correct.
8086 are the microprocessors. Okay,
Mhm.
so these are the languages which we use to communicate with the computers. Now, in 1970, there are 2 scientists who has created this Unix operating system in Bell Labs. Bell Labs. Their names are Kem Thompson and Dennis Ritchie. Have you ever heard about his name, Dennis Ritchie?
Yes. He's the inventor for the C language, I think also.
Exactly. Dennis
Yeah.
Ritchie is the person who is named or else who is called as a father of C language.
Yes.
So these two persons created an operating system. If you see Unix or else Linux also, if you see in the background, there will be certain C level programming will be there. So now these two people are coordinated and created the first Unix operating system in 1970. Okay. And from that, you have got so many Unix operating systems like AX, Sun Solaris. Okay. And then you are having BSD. Yeah. So like that, you are having so many different kinds of Unix operating systems are came into the picture. Now, and they made one point very clear. We are providing this Unix operating system as a premium cost. So everyone who is having a computer, if everyone is having a computer, they need to purchase this operating system. So then there is a person called as Richard Stallman. Richard Stallman, somewhere in 1980, he don't like that particular thing. I'm already purchasing the computer. I am already purchasing the hardware. Why again I need to purchase the operating system? What is the necessity of that? I know how to create the operating system. Then from 1985-86 in between, he started working on an operating system called as GNU. There is no full form for that. So he has he worked for that GNU operating system. And when he is creating an operating system, he has created an higher level operating system. So everything is ready, but there is a core component for this operating system. What is the core component for any operating system is kernel. Kernel is the core component of your operating system. So what is this kernel? What is meant by kernel? Have you ever heard this word called as kernel? Yes or no? Okay. Kernel is a process management or else I can call it a system management tool. I will simply say like this. So to make you understand, for example, you open an application. I open Chrome application. When I open the Chrome application, how much amount of process that I have, how much amount of processor I have to provide, or else this application should be getting, how much amount of RAM that this application should be getting, how much amount of network speed, everything, any management, process management, memory management, network management, everything will be handled by your kernel. So kernel is the core component of your operating system. Without kernel, the operating system will not work. Okay, without kernel, your applications will not run. Why? Because you can open the application. Now, who will talk in, see, hardware components will be understanding binary languages, ones and zeros. Software will be understanding the high level languages. Whenever I open a software, or else whenever I run an application, this application has to communicate with the hardware so that it will be getting some allocations. So memory allocation, and as well as, so for example, if you see, when I open a Chrome application, that will be running in the RAM. So that will be loaded inside the RAM. If you see here, that is loaded inside the RAM. This much amount of RAM is allocated, and how much amount of processing that it is getting. So this everything should be maintained by your kernel only. Kernel is the key component. So this Richard Stallman failed to create the kernel. Then there is a person called as Linus Torvalds. He created in 1991, he created a kernel, or you can call, right now we are calling it as a Linux, but in the beginning it is started like a kernel, and they both coordinated or collaborated with each other, and they developed the first Linux operating system as GNU Linux. Okay, GNU Linux is becoming the first operating system, and they made it very clear to the world saying that it is freeware and it is open source. Is freeware and open source both are same or both are different?
Both are different.
Both are different.
Hmm.
Freeware means it is there is no charge for this operating system. You can use it freely. What is meant by open source? The source code for this operating system will be available in the public domain. Anyone can access the source code and modify that. That is the reason right now there are somewhere around 5,000 distributions are there for the Linux operating system. Distributions in the sense 5,000 different types of Linux operating systems are there. Red Hat Linux, Ubuntu Linux, SUSE Linux, and then we are having Kali Linux. These are all Kali. Ubuntu will comes under the Debian. Red Hat, Fedora, and CentOS will come under the Fedora. And then you are having Parrot, Mint, Arc. So these are the different kinds of operating systems these are the different types of Linux distributions that got into the market. So, but right now in the companies, majorly every company will be using RHEL, Red Hat Enterprise Linux. It is a key component or key operating system for any company. Okay. So this is how your Linux operating system was evolved. Any questions here? Do you understand how this evolved? Any questions related to kernel or anything?
No, sir. It said that the kernel is the central part of the operating system means, sir.
Core component of the operating system. See that. Kernel is a fundamental core component, core of a computer's operating system that manages the hardware resources, facilitates the communication between software and the hardware, and controls the system process like memory and CPU. So these are all the works that will be done by your kernel, ensuring the stability and efficient multitasking. So that's why kernels are very important. If you are failed to create the kernel, then the operating system will not be done. So that's why if you see, if you give this question, is Linux a kernel? Yes, technically Linux is a kernel, meaning it is a core software that manages the computer's hardware and software. Basically, Linux is started as a kernel. Right now, we are using it as an operating system also. Okay, so here you can see what is GNU Linux. Okay, GNU Linux refers to the free Unix-like operating system that combines the Linux kernel with the GNU operating system, tools and utilities. GNU project began in 1983 to create the complete free operating system, which include the compiler, shells, and other essential software components. The Linux kernel developed separately by Linus Torvalds in 1991 and released under the free license provides a core functionality of managing the hardware and system resources. So that is what GNU Linux is all about. Okay. So this is how the Linux has came into the picture. So from tomorrow onwards, not from tomorrow, from Monday onwards, we will be working with the Linux operating system. You can also join. So Monday also you will get a free demo only, Monday, Tuesday, and then we will see. Okay. So until a basics of Linux is completed, you will get the free demos. Later that will be free. So whoever are interested to join in the sessions, you can enroll for the sessions. The fees is very, very minimal. If you like my training, then you can join into the sessions. Okay. Anything else, guys?
No, thank you.
Any questions? Okay then. Have
No,
a
sir.
nice day. Have a nice day, and we'll meet in the next session. Bye, guys.
Okay. Thank you, sir.
Thank you.
Thank you. Thank you. Next session will be on Monday.
Okay, sir.
Okay.